Welcome to Study Loop.
Okay, so this question asks us to give examples of one-to-one and onto functions. So first, a one-to-one function that is not onto. So we let fn is equal to n squared, and we have your function maps the natural numbers to natural numbers. So this is a one-to-one function because if f of a is equal to f of b, then a squared is equal to b squared, which implies that a is equal to b. So it's important to note that we only take positive square root, not negative square root, because we're only working with natural numbers. So because we're working with natural numbers, there is no negatives. So we ignore the negative. So this is a one-to-one function, but it is not onto because we have 2 is in the natural numbers, which is in the range, but 2 cannot be generated from f. So if we have n and f of n, 0, 1, 2, 3, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. But 2 cannot be generated from this. So therefore, it is a one-to-one function, but it is not onto. Now b, f of n is equal to ceiling of n divided by 2. Now this is not a one-to-one function because if we we prove by counterexample. F of 1 is ceiling of a half, so that's ceiling of 0.5, so that's just 1. F of 2 is equal to ceiling of 2 divided by 2, so that's just 1. So we have an example where the outputs are equal 1 and 1, but the inputs do not equal 1 and 2. So therefore, this is not a one-to-one function. But it is an onto function because if we let n be in your natural numbers, be in your range, then you can reconstruct this n by simply doing f to n, and that gives you 2n divided by 2, and that's ceiling of n. N is a natural number, so this is just n. Now C, onto and one-to-one, but different from the identity function. So we'll put f of n. This is a kind of tricky question. We'll put n minus 1 when n is odd, n plus 1 when n is even. So the function is one-to-one because if f of a is equal to f of b, then we have two cases. When n is odd, when a and b are odd, a odd and b odd, you have a minus 1 is equal to b minus 1, so which implies a is equal to b. When a and b are even, you have a plus 1 is equal to b plus 1, so therefore a is equal to b. So when a is odd, so when a and b are different, so that means not odd, not both odd slash even, well then a is not equal to b anyways, so there is no need for this. So therefore, for all a, so for all f of a is equal to f of b, then this implies that a is equal to b. So this is a one-to-one function. Then it is a onto function because if m is even, then f of m minus 1 is equal to m. Now if m is odd, then we have m odd. F of m plus 1 is simply m. So it's an onto function. Now, a neither one-to-one nor onto function. So f of n is equal to 0, or really some constant, doesn't really matter. So the function is not one-to-one because every number that you put into this will always give you the same number. So n f of n 0, 1, 2, 3, 0, 0, 0, 0. So you have the same outputs, all the same, but different inputs, right? So not one-to-one function. Then it is not onto because you cannot get some number like say 1 or 2 in the natural numbers because you will always get 0. So this is a one, not onto one and not onto.